You're watching PowerNation. After several valvetrain and top-end upgrades, our Big Block Chevy will be ready for the high-revving life of a hot rod engine. Today on Engine Power, we are going to be working on an engine you will probably recognize. This is our 496 cubic inch Big Block Chevy, but it is missing one distinct thing: the other engine that used to be hooked to the front of it. Yes, this is one half of our twin engine build we did a while back, where we built two identical engines, dynoed them separately, and then hard coupled them together and dynoed them at the same time on the same dyno. Now that was a lot of fun and a little nerve-wracking at times, but we made it happen. To see how it all came to pass, check this out.
Considering the stresses they would experience, both engines got parts designed for performance and durability, including a forged rotating assembly, hydraulic roller camshafts, Summit Racing Equipment's billet double roller adjustable timing sets, and TrickFlow PowerPort 320 fast as cast aluminum cylinder heads. YN Track Warrior intake manifolds and QFD 1050 CFM annular discharge carbs finished up the top end.
Engine A made 596 horsepower and 629 pound-feet of torque. We swapped the engine to test engine B, which is the power plant we are working on today. It was good for 607 horsepower and 632 pound-feet of torque. After connecting the engines and running them together, they produced 1,183 horsepower and 1,229 pound-feet of torque.
We had big dreams of putting both of these engines in a single project, but the way the cookie crumbled, Twin A has already been put into a truck project, which was perfect for the combination it had. Twin B, however, is slated for a street hot rod project, so we're going to have to make a few changes for that application. It's all going to be centered around trading out our TrickFlow PowerPort 320s for a set of their PowerPort 365s. These are going to be topped off with an Edelbrock Super Victor 2, and for the ultimate in valvetrain reliability and durability, we're going to trade ours out for a Comp Cam solid roller and their solid roller lifters. We're even going to add some rocker stud girdles from TrickFlow that are designed specifically for their heads. Because this is going to be a well-driven street car and maybe even a daily driver, we're going to be using Holley's Terminator X 4500 Stealth unit. This was designed around their Dominator carburetor and even looks like one. For accurate cam and crank signal, we're going to be using an MSD dual sync distributor. All these parts are going to take that ground-pounding torque, move it up in the RPM range, and give us some big, naturally aspirated pump gas horsepower. It's also going to be a cool representation of what a few different parts choices can result on the same bottom end. We really hate breaking these engines up, but just like in any breakup, this engine has to hit the gym and get swole.
Gains! Our teardown will start with the removal of the giant Hooker Super Comp headers that were designed to fit a Corvette with side pipes. We won't be reusing a lot of these parts, but since they only have a few hours of dyno time on them, we'll keep them in stock for future projects. There we go. A lot of times Big Block Chevys, this is a really common thing where if the bottom of it is not sealed up, it's very common that it will pull oil down an intake port and it'll smoke. So, but we always take special care to prevent this during assembly, and ours were sealed up tight.
Really like to put stuff in bags because then you can keep track of everything. When you go to put it back together, you're not looking around for the bolts. It's kind of a pet peeve of mine.
The condition of our hydraulic roller valve train is excellent. There's clearly no premature wear because there's no metal shavings anywhere under the valve cover.
Although we're not reusing the valve train on this project, we'll make sure to keep everything organized and in order, inspecting the parts as they come off. That looks really nice.
Ooh.
I mean, really nice. To perform our cam swap, we'll disassemble the front of the engine and drop the oil pan enough to remove the timing cover. Finally, we can remove our hydraulic roller camshaft. This cam made big torque and will certainly find another home in a future build. Coming up, If you want rock solid stability at higher RPM, a solid roller valve train is hard to beat. Now that we got our engine fully torn down, we can start installing some of our new parts. And like we said, that's going to be focused around switching the hydraulic roller setup for a solid roller one. People usually have some concerns with running solid rollers on the street. They think that they won't last or that you'll have to be constantly adjusting the lash. But we know from personal and professional experience, this simply isn't the case. Solid rollers have some inherent benefits over hydraulic rollers, the biggest one being that the higher spring pressures allow for much more stable valve train at almost any RPM. They also have more accurate lift and duration during operation because they don't have any hydraulic action in the lifter that can fluctuate. Lastly, the higher spring pressures also allow for more aggressive cam lobes, which can usually mean you can make more horsepower. There are a few negatives to solid roller valve train, but they're not that major. The biggest one that turns people off is the fact that you will have to add a little bit of maintenance to your schedule in terms of checking the lash around every oil change. But if nothing is going wrong, the lash should not change and usually only takes about 10 minutes to check. Secondly, hydraulic roller lifters were invented to have a quieter valve train, and solid rollers can have a little bit more mechanical resonance. If you have a car with a mild exhaust or something a little bit louder, that's usually not a big deal either. Lastly, because of the higher spring pressures at low idle RPM, the cam and lifters can sometimes not receive enough splash lubrication. But there's an easy fix to this. You simply raise the idle a few hundred RPM. For us in this street application, the pros far outweigh the cons, so we went to Comp Cams and got one of their off-the-shelf solid rollers. This cam has 267 degrees of intake duration at 50 thousandths lift and 276 degrees of exhaust duration at 50 thousandths lift. The lobes are set on a 110-degree lobe separation angle, and lift at the valve is 739 thousandths on the intake and 742 thousandths on the exhaust. We're also going to pair that with a set of Comp's Sportsman solid roller lifters that have needle bearings in the rollers, which is going to be great for longevity on the street. All we have to do now is get this cam installed and get it degreed. This cam is right out of Comp's catalog, so it has an off-the-shelf grind. It's part of their Oval Track series. We'll mock up the timing set with the timing gears aligned for zero advance or retard. Like every engine, we degree the cam, and on this setup, we put the intake centerline at 108.5, which is 1.5 degrees advanced. A critical step on a larger cam like this one is to accurately check piston to valve clearance. With the correct head gasket installed and the cold lash set, we have 140 thousandths on the exhaust side and 67 thousandths on the intake. Now that everything's all set up where we want it, we can install the cam button with some orange thread locker on the bolts and torque them to 28 pound-feet.
With ample silicone to go with the old silicone, the front cover and oil pan are bolted back on. The ARP 12-point pan bolts in black oxide finish snug it down. The API damper is reinstalled next.
That's where I'm from.
Because the timing cover was removed, we have to make sure to reset true TDC on the pointer. Valve train installation begins with Comp Cam's Sportsman solid roller lifters with needle bearings for extra durability. Our next big upgrade on our 496 is going to be the cylinder head package. Now, the 320s that we pulled off are a great head and they worked fantastic for our application, but because we were changing the operating range and the horsepower of this engine with a solid cam, we needed some more induction. These are TrickFlow's PowerPort 365 CNC heads. Now, this 365 refers to the size of the intake port, 365 cc's, and it is fully CNC ported. Moving to the combustion chamber, it is 119 cc's, also fully CNC'd, and they house stainless valves at 2 350 on the intake, 1 880 on the exhaust. Speaking of the exhaust, our exhaust port is raised 300 thousandths, fully CNC'd, and is 135 cc's in volume. The spring package on this is a serious player. These are a 1/645 diameter triple spring. Now these set up at 345 pounds of seat pressure at our installed height of 110. They have a titanium retainer with 10-degree locks that are machine steel. Now these heads flow a ton of air. 411 CFM at 700 lift and 418 CFM at 800 lift. Our cam's net lift is in the 750 range, so we're right in the sweet spot of that. Best of all, these will bolt right on where the old ones went, no problem at all. Cometic MLS head gaskets in a thinner 27 thousandths thickness will tighten up our quench area nicely. Combined with our new cylinder head, we have a measured static compression ratio of 10.55 to 1. These heads and gaskets were in stock at Summit Racing Equipment, and we got them in no time at all. These heads have the same bolt column heights as the 320 heads we removed, so we're able to reuse the ARP 8740 head bolt kit. The heads are torqued in multiple steps to a final value of 70 pound-feet. Up next, the Big Block gets a front accessory drive that's simple to install and looks super slick.
And then we're off to the dyno cell. We ordered these high-tech one-piece push rods from Comp Cams. They are 3/8 in diameter, have a 135 thousandths wall thickness, and are 9/750 long on the exhaust and 8/780 long on the intake. To handle our high solid roller spring pressures, we're using a set of Comp's 1.7 ratio Ultra Magnum XD steel rockers. We'll install them in the firing order and temporarily set them at 0 lash. We've already aligned the guide plates and torqued the rocker studs to 55 pound-feet.
The rocker stud girdles are installed next. These will provide extra support to minimize rocker stud deflection and improve valvetrain stability. It's very important that the lash is set with the girdles installed and tight. Our cold lash setting is 12 thousandths on the intake and 14 thousandths on the exhaust. Weather strip adhesive is used to hold the intake gaskets in place. These SCE gaskets are recommended by TrickFlow and are matched to these heads. We've painted this Edelbrock Super Victor 2 to match our engine. It has a larger cross-sectional area to complete our upgraded induction. To improve coolant distribution, we built these coolant crossover lines using Earl's AN fittings and hose. They are our go-to because their swivel seal fittings are high quality and easy to assemble. Comp's valvetrain assembly lube will protect the springs and rockers on initial startup. With that, we'll reinstall our Summit Racing gasket and valve covers to seal up our top end.
In order to get our engine ready for the street, we're not only using Holley's fuel injection, but we're also going to be using their new Big Block Chevy mid-mount accessory drive. It's all based around the water pump housing, which should look pretty familiar because they designed it based off an LS/LT style water pump, which means it has a cartridge style water pump and integral bracketry, so everything in the kit bolts directly to it, so it's easy to assemble. This kit comes with quality components like a Type 2 power steering pump, an SD7 AC compressor, and Holley's own alternator that's based off a Corvette design. It comes with all the pulleys you need and even includes things like an idler bracket and the correct size belt, covers to give the kit a clean look, and all the fittings, hardware, and pigtails you need to put it together. It should be really easy to assemble, so let's get it on. This pulley is designed to bolt right to the balancer, but it can be machined to fit a crank trigger system if necessary. The kit comes with O-rings or paper gaskets to seal the water pump housing. Because our stock block has a mild amount of corrosion, we opted to use the gaskets and a little bit of silicone. The instructions come with torque specs for every fastener. The 3/8 upper bolts are torqued to 30 pound-feet. Putting together the rest of the system is super simple. Everything bolts right in place, and we don't have to worry about pulley alignment. Once the belt and all the covers are installed, we'll take a good look at this slick front drive. We're going to be topping this engine with Holley's Terminator X Stealth 4500 throttle body injection unit. Now this thing is massive, and like we said, it's based off the Dominator design and even is supposed to look like one. But it's designed to flow a ton of air and support a bunch of horsepower. It has 2 1/8 inch throttle blades that flow up to 1,440 CFM. And underneath the mock fuel bowls, it has 8 100-pound-an-hour injectors, so it can support up to 1,500 horsepower naturally aspirated and 1,250 horsepower under forced induction. We're probably not going to be using all of that, but that's pretty cool, and that's a ton of power. It has an OE quality wiring harness that's nicely routed, and it goes into the same Terminator X ECU that Holley uses on all of their Terminator X units. So it's really easy to hook up, and this one only took about 5 wires to get it ready to run. It has a really nice self-learn function that lets the unit adjust the fuel flow to match your desired AFR on its own. And it has a really easy startup wizard, so it's quick and easy to get this engine running. You can do all of that with the included handheld, or if you want to get a little bit deeper in the tune-up, you can use Holley's free laptop software. In order to give the ECU an accurate crank and cam signal, we're going to be using MSD's dual sync distributor. These are really nice because it's plug and play with the unit, and it allows us to use the integrated ignition timing control in the unit, so we can build a custom ignition curve for this engine. Because it's plug and play, this whole thing should be really easy to install, and we should have this engine running pretty soon. With the fuel lines hooked up and the wiring harness plugged in, we're bringing it home for the big win. Up next, another good day in the dyno cell. Oh, snap! Heck yeah!
For all intents and purposes, we have a different engine. It's the same engine, same bottom end, but with the induction change and the stuff on the front of it and all that, it's a different engine, so we're gonna have to run it different. So we've ran it, and it actually fired up nice. The programming, we have target air fuels where we want. We messed around a little bit with timing, and we made some easy pulls, and everything seems happy. So what we're gonna do, I think we're gonna change the RPM range from where we start. So I'm gonna go 3,500, and we're gonna go to like 6,000 and see what that pull looks like.
This is like a street engine, so I feel like this would be like the streetable range. This is where you'd be, where you're driving down the street,
right.
You step on it, this is what it would do. It's not going to make peak power in that range. We already know that because we've cammed it. We've changed the induction to move the, the peak torque way up in the range, move the horsepower way up in the range. But I think this will be a good indication of, like, quote unquote, how the engine would drive down low.
People think that if an engine makes power way up high in the RPM range, that it doesn't drive well down low. Simply not the case most of the time because of gearing, and because when you have something that's very adjustable from a fuel standpoint on like something like this, it will meter fuel and behave very well.
Yeah, and a lot of times when you're driving around, you're at partial throttle, you're in a transition, which is where the fuel injection is really nice because it's really easy to compensate for that. You can tune it in very easily. See what she does.
Love the sound of this thing already. Already better than where we were.
Yeah.
642 horsepower and 567 pound-feet. Now it's still learning a little bit.
Yeah, but 567 right at 5,000.
And we're nowhere near peak.
Oh no, so that's still going to go up, but that's pretty cool. 496 cubic inches, peak torque at 5,000 RPM.
Yeah.
I think we got to step up that range a little bit, right?
I'm going to step it way up.
Because I mean, we put this combination together where it would make, good peak torque. Obviously, we're down a little bit from where it was before because the combination has completely changed. But now we've changed it so that it will make peak power somewhere in the 68 to 7,000 range.
It's going to make it around, I'm going to say close to 7,000.
Yeah, it's going to be really close.
So just to make sure we hit the peak, I'm going to go 7,200. So okay. I'm going to make a pull from 4,500 to 7,200. Clean right through the pole.
Dang.
730 horse, 574 pound-feet.
Yeah.
So
peak horsepower still happening right at 7,200. That's right at the top of the pole.
Now we can turn it higher. We're starting to get into a piston speed situation where it's starting to get a little spicy.
Yeah, I did the math on it. At 7,200, it has an average piston speed of over 5,000 feet per minute.
That's pretty good, but
it's pretty fast.
but okay, that's okay because we have good parts in it. We have a good crankshaft in it.
Yeah.
We have an H-beam rod with an L19 bolt in it, and we have a good piston in it. I think we can get a little bit better. Let's mess with the timing a little bit.
We were at 32 degrees, which was relatively conservative because pump gas still, we're on 93 octane right out of the pump. So we usually keep them pretty safe, but we made a big jump. So
that's a big jump.
32 to 36, relatively large jump, so let her rip.
I think it broke 750.
I think it did too.
That's pretty mean if it does.
Oh, snap. Heck yeah. 752.5. 752.5 at 7,100. So the graph is, I mean, we can overlay them, but it pretty much looks the same. It kind of, instead of looking like it was going to keep going, it kind of, yeah, it kind of dipped over.
If you overlay it.
586.9 pound-feet at 6,000, which that's just because that torque curve is so flat, it kind of trades. Yeah.
But see how the graph is like literally identical?
Oh yeah, it just moved it up.
It just moved it up. You know, little timing goes a long way. You know. All right, what do we got for?
1.517 per cube.
That's nice.
That's pretty good for 93 pump gas. You know, right out of the pump.
When you're above about 1.4 on pump gas, you're doing well, right? Anything after that is a bonus. But
yeah, I mean, having the full accessory drive and the fuel injection is kind of what helps tame it into like a street engine, you know?
I'm impressed with the Holley's system too.
Oh no, I mean, it literally bolted right on there. It looks great. Yeah, and it gets you everything you want in a nice, compact space. You know, we could drop this in anything. Like we could put it in a truck, in a car, whatever, and it would fit, you know? So that's super nice. But
yep, I dig that.
Yeah, that's awesome. Heck yeah, good job.
Good 8/6. For more exciting builds like this bad to the bone Big Block, check out PowerNation.